In this video, we're going to take a look at the distributive property. Now, the distributive property is not provable, and so we're not going to take a look at the why behind it. We're just going to assume that it works. Here's what it says. If you have three real numbers, a, b, and c, then if you have it as a times the quantity b plus c, you must distribute that multiplication to both the b and the c, so that you have a times b plus a times c. That's all it is. You're just distributing multiplication over addition. So here's how it works. I'm going to go ahead and the way I run this for myself is I always want to be sure that I get my signs correct. And by signs I mean by positives and negatives, because I tend to make a lot of mistakes in my signs, just like a lot of people do. So what I'm going to go ahead and do is I'm going to go ahead and circle that first number, and I'm going to include whatever sign's out in front of it. And I'll show you that in the next example. And then I'm going to draw lines, and these lines are simply going to point as to what I'm going to distribute to. So 3x plus 5 becomes 3 times x plus 3 times 5. Well, this becomes 3x plus 15, and that's our answer. And that's all it is. That's the distributive property. Now, it works for all kinds of different numbers. In fact, it works for all real numbers. In fact, it can be extended. So if you're studying polynomials, for instance, the distributive property works in polynomials. If you have no idea what I'm about to say, just kind of ignore it for right now. But if you've ever learned the thing called FOIL, ew. First of all, FOIL is an acronym and a mnemonic device. It helps people remember how to multiply two binomials. It's nothing more than distributive property. That's all it is. It's just that we found out that this particular setup has kind of a unique way of looking at it, and we can make a fun name out of it. Great. It only works with binomials. It doesn't work with anything else. So I don't personally advocate for it, but that's fine. If you like to use it, that's cool too. On the second, again, I'm just simply going to gather up my sign and the number in front, and I'm going to distribute that that multiplication over addition. And so I take my negative 4, that's going to give me negative 4 times 3x plus negative 4 times 2. You'll notice that I'm keeping the plus. This plus is always staying in my problems. Now, I'll show you a shortcut around that in the next one. But here I've got negative 4 times 3 is a negative 12x plus negative 4 times 2 is negative 8. We can rewrite that as negative 12x minus 8. And so this kind of gives you a hint as far as, if you notice, we have negative 4 times positive 2, which gave us a negative 8. The signs and the operations can kind of be interchanged. So let's take a look at another one. In this example here, we're going to take that same negative 4 and that same 3x, but then we're going to say, oh, well, we can go ahead and distribute this. But there's a negative there. How do we do that? Well, we just make it look a little different, and pretty soon it starts looking like something that we're supposed to see. We have our negative 4, and then we have our 3x in here, and that's okay. We know how to work with that. But we're going to change this subtracting 7 to adding a negative 7. Now we're adding a negative number. Remember, these numbers can be any real number. So c can be negative, that's fine. And now we can proceed. So we take our negative 4 and we distribute it to our 3x and our negative 7. Well, negative 4 times 3 is negative 12x plus negative 4 times negative 7 is a positive 28. Well, we could simply rewrite this as negative 12x plus 28. And that's how you deal with subtraction. It's no big deal. So in practice, what do you really do? Okay, yeah, so we've gone through all this stuff, and now we've done it the proper way. So how do we really do it in real life? All right, well, here's real life. Let's take this last problem here. In real life, we're simply going to grab up that first number, distribute it to the first and second numbers inside the parentheses. Then, when we multiply, we're going to multiply to include whatever sign is out front. And we're going to use that sign as the actual operation. So, when I distribute this, negative 4 times positive 3x gives me a negative 12x. But a negative 4 times a negative 7 gives me a positive 28. And it works every time. It's simply how you rewrite subtraction. That's all it is. So the distributive property is not really that bad. Now, one thing I want to point out, and I will show you a couple things in the next video. The first thing I want to point out is you'll notice the equal sign. That equal sign allows this to go both ways. When you go forward, meaning that you distribute, it's typically referred to as distribution if you go in that direction, or expanding. Expanding is more for polynomials, but that's no big deal. If you go backwards, so you're heading back this way, this is more commonly known as factoring. So you are given AB plus AC, and you have to factor out the A. All right, this is known as factoring. It is the same principle. The same property allows you to do both. It's not different. So I'm just trying to help you in that regard. Once you've learned the distributive property, you can go both ways, but it might be a little tougher to factor than it is to distribute.